Okay, try again. It's not the 20th. This is great. Okay. Welcome to Free Prep Hour for January 22nd, 2025. I'm Dmitry. I'm your slightly befuddled host. We're going to talk today about section timing for an entire section. So we're going to do a simulated quant section one. It's not going to look exactly like a regular quant section, and I haven't, perfectly recreated the balance that you'd see on an official section. But I want to make the idea of it, so that we can think about how we time ourselves across a section. All the problems you'll see today are in our 5-pound book of GRE practice problems, available at finer retailers everywhere. So we're going to focus on doing the full-time section and reviewing for efficiency. Um, okay. So what does a section look like? As you may know, on the GRE, you get 2 sections of quant, 2 sections of verbal. In each section, the first section is, or in each test, the first section of the two is sort of a mix of difficulties along the middle of the road, right? Can range from easy to hard, but it is on the more average side. And then depending on how you do, you get a harder second section, a medium, or a lower second section. So it's really important to do well on that first section if you're shooting for a fairly good score, because you want to just miss a handful of questions to get to that harder second section. Typically, we're aiming to miss no more than about 3 out of the 12 questions on the initial quant section. So structure-wise, what's on a quant section looks like this. And there's no guarantee that it'll be done exactly this way on the GRE, but this is what we typically see. The first 4 questions are quantitative comparisons. Those are the ones, if you've seen them, that ask you, is quantity A bigger? Is quantity B bigger? Are they both the same, or does it depend? Right. And so if you've never seen one of those, the answer choices will be on the bottom left on these slides. But that's what they're asking, right? Can you tell which column is bigger, or does it depend on what the numbers are? Then you'll get typically just one regular quant question before they put you into a data set. And then you'll get more regular quant questions. The second section is fairly similar, but it takes out the data set. So and you have 15 questions. So you'll have 5 quantitative comparisons and then 10 regular quant ones. So the way I think about timing typically on a section is something like this. The initial 4, the 2-column quantitative comparison questions are meant to be done fairly quickly. And because of that, I like to time this as just 5 minutes for the first 4. So that averages out to 1:15 each. Since I'm screen sharing, I'm going to move the things along in a somewhat artificial way, right? So you'll be forced to move to the next question every 1:15. But that's a good way to practice getting as far as you can under those circumstances. And certainly if you're watching this as a recording, you could choose to do it differently. At some point, when I start putting up questions, you could just set a 21-minute timer. And you could do this if you're even participating live today and you want to do it again later. You could set a 21-minute timer and kind of pause and work through as needed to get through the questions in that 21 minutes at your own pace. And that's of course what we will normally do when we're not screen sharing. But there's something to be said for thinking about, what does that 1:15 pace feel like on a quantitative comparison, and what does that 2-minute pace feel like on the rest of quant? On data interpretation, um, you know, it's going to be a little bit like a reading comprehension, where you may need a little bit more time on the first question than you do on the subsequent questions. But given the nature of the set today, I think it'll be relatively safe to spend exactly 2 minutes per question. Um, so the normal benchmarks would then be, if you think about the questions completed and the time remaining, the idea would be to say, okay, after those first quantitative comparisons, want to have spent 5 minutes. You have 21 minutes for your first section, so that would mean you would want to have 16 minutes remaining. And then after the next 4 questions, which would be the first discrete quant and the data set, you'd want to have then done 8 questions. And if you're seeking a target of 2 minutes per question for those, that would be another 8 minutes. So you'd have 8 minutes remaining. And so that would be the 2 main check-ins I'd have. And of course, by the end, I'll have 0 minutes remaining at least. When I'm actually doing these, not in a workshop setting like this, I may well aim to be done earlier, so I have time to review as needed. That'll be harder to do today, but it's something to think about when you go through these questions the first time. If I make you move on, You might think about as you're moving on, okay, I'm going to write down an answer and I want to write down an answer for each of these, right? But do I think that I have it and I'm good with this? Am I pretty confident that I don't have it? Um, is it something that I might want to return to if I had a little bit of time? And even though we won't be returning to them as part of a time experience, that's something I want to think about when I'm working and reviewing. So for each problem, you might think about what's your confidence interval, and would you flag this one to come back to specifically? Would you mark this to return to on a test if you had time? And then ideally, when you're practicing, you want to stay ahead of these benchmarks. So if you find that when I'm moving on slides, you typically are already done, great. Then you're staying on top of pace as well as possible, even if your accuracy is not perfect. This is good. If you find that every time I move on, you're like, but I need more time. Where's that time going to come from? Right? It might it might come. It might be that you skip a question at some point. And by skip, I just mean fill in an answer and move on. Right? You don't leave it blank. Um, but you might well skip a question or two that aren't looking as promising to maximize your overall. And I think one thing that's really important about our work process and our review is that we're working on efficiency. I'm not just trying to be as accurate as possible on every single question. I'm trying to be efficient. And what I mean by that is that I want to have the overall maximum number of points per section. Right? I want to get as many of these 12 questions right as I can. And sometimes that's not well served by saying, I'm going to get number 4 right if it kills me. Maybe I should let number 4 go in the interest of the overall. That's something to think about as we review. So what I'm going to do is I'm going to put up each question one at a time. You'll see four quantitative comparisons. You'll see one discrete quant, a data set, and then you'll see 4 more discrete quant in order. And I'll just keep moving the clock on relentlessly at those time intervals. So see if you can have your answers written down as soon as possible, and then review as much as you can until I move the page. Right. This will be a little bit of an artificial experience compared to what I would normally have you do at home, which is to time a set. Right. If I'm going to do this many questions, I'll give myself this many minutes, and I have some give and take. And that's, of course, what you have on the real GRE. But it can be good practice to time with that more rigid timing just to get a feel for it. So that's what we're going to do today. All right. So if you need to take a moment now to make sure you have something to write with and some scratch paper because you're going to want to have room to work 12 questions and write down your answers. So if you need to do something, if you need to grab something, we'll have about a minute or so to do that. So take this minute to get what you need. Then I'm going to put up the first question and I'll start moving on at intervals. If you want to set your own timer so you have a better sense of when we're moving on, you can definitely do that. But again, on the first 4 questions, I'll move on after a minute and 15 seconds exactly. On the subsequent questions, I will move on after 2 minutes. Okay, so another 30 seconds or so to grab anything that you need. Questions for me before we start? And then once we're done with the set, we'll run through and review with an eye toward, of course, what are the answers, but also what's a reasonable way to do them? What's a way to be efficient if it wasn't showing up for you as a very efficient question to do under the time situation. Okay. All right. So if you want to set your own timer, you can, but I'm about to flip over to the first question in just a moment. So aim for a minute, 15 seconds. Again, the answer choices will be at the bottom left. Um, A is always bigger, B is always bigger, C means they're always equal, and D means it depends. It might be more than one answer. Okay. And here we go. So I'll do an auditory warning for this one. If you haven't already, take a moment to write down your answer A, B, C, or D for this one. And we're going to click to the next one. Here we go. Here we go on to the next one. Okay, we're going to move to our last quant comp. All right. From now on, we'll be doing discrete quant. So every problem after this will be 2 minutes. Starting with this one, we'll have 2 minutes per question. Okay, make sure you have a letter answer, and here's the next one. This will be the 3 question set, one at a time. Here we're going to go on to the second one of 3 for this. Okay, we're going to do the last one for this set before we move to regular individual questions. Okay, we're going to go back to individual questions, not sets for the last four. A couple of these will not be standard multiple choice, just so you know. Okay, moving on to number 10 of 12. This one will be a fill in the blank, so you've got to spell your own answer. Okay, so even if you didn't get an answer you're satisfied with, put a number down anyway, even if it's just a wild guess, put a number just to get used to that. We're going to go to number 11. This one is a choose all that apply, which means it may have more than one answer. In fact, I'll tell you it does have more than one answer. Try it. Okay, take a moment to write down all the answers you think might apply to this one. Again, spoiler, more than one of them is the answer. And we're going to go to our last question. 2 minutes for this one. Back to regular multiple choice. Okay, and take a moment to wrap up and put down that last answer. And we're going to stop. Okay, there we have it. So 21 minutes. How did it feel? Love to get some feedback in the chat. Were these hard? Not so hard? Did you feel like you were able to handle the timing? Or were there places where the timing really pinched? What did you notice? I wish I could get you on mic, but since I can't, just quick notes in the chat would be interesting to see. Um, one thing to think about would be, are there places where you would have liked more time and there are places where you think you could have gotten by with less? So did you find there was a lot of unevenness there? Were there questions that were finishing 30, 40 seconds early and other questions that you didn't think you had time for and you would like to reallocate the time on your own? Something to think about. Um, of course, obviously, some of them are harder than others, and that's going to vary from person to person. But it's always worth looking back as you review to say, okay, given that, where did I want to put my attention? Maybe there's a problem that's really hard, and I can review it. But the biggest takeaway for me might be I shouldn't have invested so much time in doing that problem. Compared to another problem where I say, that one made a lot of sense for me, but I was just a little inefficient. So how can I get 10% faster? And in the meantime, when I'm not 10% faster, can I buy time from somewhere else? If I need 2 minutes and 22 seconds or something, okay, I can have it on the real test. I don't have to get cut off by an annoying proctor after 2 minutes. But I do have to pull that time from somewhere. Another thing that's worth looking at in this is what they do to you at the end of a section. So if you notice, I replicated something that the real GRE tends to do too, which is that, okay, initially in the section, you have those quantitative comparison where there's just four answer choices. And so your chance, even if you guess randomly, is 1 out of 4. And if you're able to narrow down, which you often can, then it's 1 out of 3 or 1 out of 2, which is not, not bad odds. Then we get to the latter parts of the test, and we suddenly start having a fill in the blanks. There are ways to guess this, and there are ways to narrow it down. Maybe you successfully figured out that it has to be more than 88 to be the greatest when the average is 88. And maybe you even figured it's probably in the 90s. And so in a sense, you have multiple choice. You're like, all right, it's probably in the 90s. Which number in the 90s is it? Maybe I can narrow it down. Maybe I can test a couple. Um, but it is harder to guess on these, and certainly you need a moment to read it versus a question where you could, even if you hadn't read it, you could just quickly go, hey, and have a 1 out of 5 chance or 1 out of 4 chance of getting it. Same thing for choose all that apply. These will vary. Some of them, very commonly, I feel like they end up being in a range. So it'll be several consecutive answers that are right. And so when in doubt, I would probably choose some answers that were consecutive to each other. There does have to be at least one answer. There doesn't have to be more than one answer, although I mentioned that on this one there is. And the answers don't have to be consecutive. The answers could be 2, 8, and 12, right? But sometimes it's useful to think about like where my values lie and what's getting excluded. But my point about timing here is that these are problems that are almost designed at the end of a section to punish you if you haven't had time, if you haven't allocated enough time. Now, here you avoided that punishment because I was moving you on, moving you on, moving you on. But a lot of folks tell me I just can't finish a section, and so they're slowing down elsewhere in the section, and then they are not having time to answer these questions, and their chance of guessing right is almost zero. Then at the very end, I went back to a regular multiple choice question, which I hope you'll agree once we look over it, you can narrow down quite a bit, and you might be able to, get right, but you could also make a decent guess at even if you were short on time, but not again if you're timed out and you don't even have time to really look at it or think about it at all. So stuff to think about as you're proceeding. All right. So we'll run back through the section and see how we're doing, see what the answers are, of course, and also how we can do them more efficiently. For each one, I'll have you pull in what you got. So I'll just use a pull function. My polls are usually A through E. So obviously for these, we'll ignore E. So just pull in what you got on the A through D scale. Again, A meaning quantity A is always bigger, greater, right? Greater is not quite the same as bigger, right? Because a bigger negative number is still lesser, right? Um, B says quantity B is always greater. C says that they're always equal. And D says that it can't be determined, that it depends on the numbers. Often what you'll find on these is you can narrow down one or the other. You can either say, um, I'm looking for D, I'm trying to see if I can find more than one case, or I know that the answer is not D. And this one, I think, hopefully we can all agree, and pick this answer, that the answer can't be D because these are real numbers. And I might not know or have time to find out which side is bigger, but there is an answer. And I think we'd all agree that, if we had all the time to calculate and we did it accurately, we would certainly not find two different answers, we'd find one answer. And so D is out automatically. If there is a knowable answer, then it's not D. And so if I have to guess, I already have a 1 out of 3 shot. From here, I have a couple options. I can cancel up and down, or I can cancel side to side. So the most normal way, if I were going to just calculate all this, of course, I do have a calculator. So I could just I would probably calculate the bottom first. So if I were going to do it on a calculator, I do 4 squared times 45 times 45 and write that down or put it into the memory of the calculator. Clear, then calculate the top 75 times 9, if you will, or times 3 times 3 times 2 times 2 times 2 times 2, get all that, and then divide by that denominator that you determined, divide by what's in memory. Um, because really what we're doing is we're saying all of this on top divided by all of that on the bottom. But if I want to make my job a little simpler, I could cancel up and down. So for instance, I could say, 2 to the fourth is 2, 4, 8, 16. 4 squared is also 16. Great. These can go. Not 30 squared is 9. 9 over 45 is 1/5. And so then I can say, all right, so I've got 75 over 5 times 45. If I divide 75 by 5, I can recognize that 75 is 3 times 5 times 5. I cancel one of my 5s. And now I have 15 over 45, which is 1/3. And I can do the same kind of thing over on this side. It doesn't have quite as many nice factors, but I know 2 squared is 4. So if I have 4 on top and 4 squared on the bottom, the squared disappears. Same thing here, 3 squared and just 3. So one of the 3's will cancel out the squared from that. So now I'm going to have 30 over 4 times 25, which would be 30 over 100, which is 3/10. If you know that the third is 0.333, and this is 0.3, then A wins. Great. I think, though, that it's a little easier to cancel across, right? And one method we'll talk sometimes about in our courses is the hidden inequality, the idea that I really want to know which side is bigger, and I can even think of it like this. And then I can do anything I would do to both sides of an inequality, which means I can add or subtract, and I can multiply or divide by a positive number, by a known positive number, right? A negative would flip the sign to get us in trouble. We don't have anything like that here. So what that basically means is I can cancel from both sides. I can say, look, both sides have 3 squared, so let me ignore it. And in a comparison, that kind of makes sense in general. It's like if I said, you know, who who has more money? Someone with twice as much money as me, or someone with twice as much money as you? We can get rid of the twice as much and just compare what we have. So we can get rid of these, we can get rid of those. And then I could keep canceling across both sides, right? So that, for instance, I might say, I see two fives here. Let me cancel two fives from this side. Now I'm not going to find the actual values of these two sides, but I'm still going to be understanding the relative values of these two sides, right? And so I could stop here and put this together, or I could keep canceling, right? I might take a two squared out and leave a two squared here, aka four. Um, at this point, I might stop. I might say, okay, so I have 75 times four over 9 times 9. And that's not the actual value of the left-hand side, but it's going to still allow me to make the comparison. If that's bigger than 10 over 3, then A wins. Um, and so I can, try to eyeball that, or I can keep doing some more cancellations, right? So for instance, if I cut another 3 from here, another 3 from here, right? I have 10 versus what is this? 300 over 27. Well, hey, that's more than 10. How do I know? Because 270 over 27 is 10. So that's more than 10. So A wins. So for some people, that's a less helpful way, but some of you might find that at least some of that you'd like to do. And at the very least, I can cancel common terms from both sides and then simplify from there. Okay, so that's number one. Strategy wise, though, make sure you're getting rid of that D right away. Whereas here, maybe you pull this one. Here, I can't immediately get rid of D because I don't know what X, Y, and Z are. So I don't know that there's just one answer. So what do we get? Now, here I'd be cautious. A lot of folks fell for a trap on this. And so here's something I want you to watch for when you're doing these. First off, when I see that there are unknowns like X, Y's, and Z's, I want to suspect that it's at least possible the answer is D. D is no more likely than any other answer, but I just want to at least expect that it's possible. But here's the other thing. If I look at this and immediately say, hey, X, Y, Z is more than half X, half Y, half Z, that has separated me from exactly zero test takers, right? In other words, there's no one taking the GRE, pardon me, I'm hitting myself. There's no one taking the GRE who doesn't know that X is bigger than half of X. So you have to question, is that really what they're testing? And in fact, I would say, look, this can definitely be the case. A can be bigger, but is it always bigger? Probably not. If I were in a hurry, I would pick D and I'd move on, and I would be right. So how do I know that? Well, first, I can just pick really easy numbers. Let's say I say X, Y, and Z are, you know, 2, 4, and 6, right? I can know that the average is the one in the middle, or I can add them up and divide. 6 plus 4 plus 2 is 12, divided by 3 is 4. That's the average. And so what would half be? 1, 2, and 3. The average is 2. So clearly, A can be bigger. What that tells me, and this is a really important thing for quant comp, if I prove a result, if I say, hey, this time A was bigger, that means I get rid of the other two out of BC, right? It's not always B because it wasn't this time. And it's not always that they're equal because they weren't equal this time. But then I say, okay, sure, that's the result I got this time, but can I get a different result? And I actively go looking for a different result. I try to find an exception. So what happens? What could happen where having X, Y, and Z doesn't make B smaller than A? One quick way to do that would be to make them all zero. Didn't say they weren't. So then these would still be zero. Then they'd be equal to each other. That would correspond to an answer of C, of crossed out C, which tells me my answer is D. Another option would have been to do negative, right? If I made X, Y, and Z negative, if I simply change this first case to negative, then the average of A is -4, the average of B is -2, -2 is greater than -4, which is why I corrected myself when I started to say bigger, right? Bigger is a more loaded term. I might think about absolute value, but -2 is greater than -4. I would flip that around if the numbers were negative. So suspect that. If you fell for E, you're being, sorry, if you fell for A, you're being a little too trusting and saying, yeah, bigger is more. And it's like Jerry is meaner and trickier than that, a little sneakier than that. Okay. Number 3. Pull this in. Even if it's a guess, just toss your poll answer in there, A, B, C, D. Here's another one where I can't immediately cross out D because they said the train ticket cost was between 44 and 50. So the whole issue then is, does that prove, is it no matter where I am between 44 and 50, I could have more kids or I could have more adults? Or does it prove that one is bigger than the other? Does this limit, right? And this gets to the idea of weighted averages, which is one of the main things this is testing. Um, so there's a couple ways I might think of this, as I might say, well, first off, let me look at the extremes. There are 6 passengers. What happens if they're uh, all kids? There's no adults. They're just kids running wild. That would be 6 times $6 is 36. So it's not that because the cost of between 44 and 50. And it's all, if it's all adults, then that's 6 times $9 is 54. So it's not that either, right? So what we've proven already is that it's not all kids, it's not all adults. It's a mix of the two. But that doesn't tell me yet whether that range of 44 to 50 allows me to have more kids or more adults. So I might then think about, what if it's 3 of each? That would be 3 kids plus 3 adults. You can use your calculator as needed, but that's going to be $18 plus $27. It's all multiples of 9, interestingly. So what is that going to be? That's going to be $45. Now that's a really interesting result. $45 is in between 44 and 50. So I found that they could be equal. I could have 3 kids, 3 adults. These are equal. Does that prove C? No, it just proves that they can be equal. So what it does is it disproves A and B. These are out because these say that A is always bigger or B is always bigger. Maybe one of the times they are, but not always, right? So now my goal would be to prove D, and I could do that by switching in either direction, right? Now I can't really have there be more kids because then I would slip below. I'm already at 45, and if I switch one of the adults for a kid, we're going to save $3 and we'll be down to 42. But if I switch over, plus 1 adult, instead of saying 4 adults, 2 kids, I'll just say plus 1 adult minus 1 kid. That's going to be another $3, right? It's $9 instead of 6. So that'll be 48. That's still in the range. So what this tells me is I can't have more kids than adults, probably just for the best. So I've done field trips, they're hard. But I can have equal or I can have more adults than kids. So the answer is D, right? And that's a weighted average kind of thinking, right? To sort of think about, where's my break even, where are my edges, right? Even if I didn't do all this, even if I just stopped where it says all kids are 36 and all adults are 54, and I found the halfway point of that, the halfway point of that is 45. It's a 45 that we find next. And so if I know, hey, it's possible to have a break even there, but I can also shift over to more adults, that would prove D. Okay. Number 4, this might for some people be a non-starter. If so, you can narrow it down. Here's one where, again, I would think about, is this going to be one about testing cases or is this one about provable? And now they talk about the greatest possible value for X, so it sounds like I need to test cases. But there has to be an actual greatest possible number, given that they've told us what we're dealing with. We're dealing with 10 factorial, 10 times 9 times 8 times 7 times 6, etc. Right? That's a 10 factorial list. And so here's one where I can go back to crossing out D. I know that the answer can't be D because there has to be a number that represents the greatest possible value of X. There has to be a number that represents the greatest possible value of Y, or twice that. And so it's not D. And again, even if I have no idea on this, I've got a 1 out of 3. So if this felt like a non-starter, rather than spending a lot of time on it on a test, I might just be like, okay, I've got ABC, let me see. So then from there, I want to say, okay, what are we talking about? 3 to the X, 5 to the Y. What these are talking about how many powers of 3, how many powers of 5 are in this factorization. So where am I going to find my 3's? Well, let's see. I've got multiples of 3 in 3 places, 3, 6, 9. But 9 is 3 times 3. So it's got 2 powers of 3, right? And I'm not talking about how many total multiples of 3 there are, because of course 6 is 2 times 3, And that, that would might seem like, okay, I've got three, four, five, six threes. But in terms of powers of three, if I multiply this all out, how many times does three get multiplied in? It gets multiplied in once in three, once in six, and twice is nine. Three times three times three times three. So the answer to this is four. There are four threes in this number. Whereas for y is twice the number of fives. Well, where are the fives? I've got a five here. I've got a five here. I don't have any five squares. I don't have any 25s. There's two fives. That's four. This one is C. Okay, so there's our quant comp. So one thing to think about as we move on to the discrete part of the test is, was I optimizing this? Was I narrowing down as needed? Was I identifying whether this is one where I might try to prove D or where D is impossible? That's a really important distinction you can make. And then if I am trying to prove D, um, that means anytime I get a single case, like, hey, XYZ gives me a bigger average this time than half X, half Y, half C. All right, well, then it's A or D, and I'm actually aiming to find an exception then. If I can't find an exception, that's when I would pick A or whatever one I found before. Okay. Switching gears for this last stretch to the regular discrete quant ones. Uh, Pull this thing in. Gang of criminals. I imagine like an old black and white movie with, the fancy 1920s car and all that, corny dialects and all that. But okay. So, they hijacked a train. The police are chasing them. We can build this story out. And one way we can definitely do this, something like this, is to visualize. And I might narrow down like what happens, right? For instance, I might say, if they're 50 miles away and the train travels 50 miles an hour, then in 1 hour the police can't catch up, right? So I might at least say, hey, it's not A, right? If here's the starting point for the train, and they head due south, and they're going 50 miles an hour, but they're also 50 miles ahead. I could think of it like this. After 1 hour, they've gotten 100 miles ahead of the cops' starting position. So meanwhile, what's happening to the cops? They start here, but in an hour they go more than 50 miles. They go 80. So they're catching up for sure. But what we can see is that at this point, the criminals, after an hour, the criminals are still, whoops, I didn't want to arrow there, are still 20 miles ahead of the cops. So what happens after a second hour? Well, it looks like the cops are going to catch up. I add another 50, that's 150, but I add another 80, and that's 160. So what I can tell is in 1 hour, the criminals they've only traveled 100 miles, but they're 150 miles south of the top of the line, right? And the cops are 160 miles south. They've passed the criminals at this point. So it's not 2 hours, and I could cross off D and E. And so if I had to guess, a decent guess would be B or C. If I want to fine tune it, the most common way to think about a chase problem is to subtract the rates. So I simply say, how fast do the cops catch up? They're catching up at a rate of 30 miles per hour. And so I can say, all right, if rate times time equals distance, if the cops are catching up at a rate of 30 and the distance is 50, then rate times time is distance. Time will be distance over rate. It's 50 over 30. So time is 5/3 of an hour, which is 1 2/3 hour. You can calculate 2/3 of 60 is 40 minutes, or you could just say it's more than an hour and a half. So it's C, not B. Is that all right? We'll hit the set real quick. This first one, now it's a little mean because I gave you exactly 2 minutes to do this one, even though you have to process the information as well as answer the question. But I kind of figured that maybe this was a faster question to answer than some of the ones that followed. So hopefully I adjusted correctly for that. But of course, on your own time, you can do it how you want. Um, One thing that I thought here, Go ahead and pull this one too. One thing that I found a little bit mean about this one is they say which 2 month period, and we have to really think about what they mean. At first glance, I might think two intervals, like from May to July. No, they don't give you an answer like that, right? But when they say 2 month period, they're really just talking about one change, right? A 2 month period like January to February is one click on this, right? So we're looking for a greatest increase. A lot of these don't have increases. So even whether I eyeball the chart or look at the answers, I can say, well, clearly, um, there's not much increase going on here. These are decreasing. This one is a very mild increase. In the book, we have a question on this set that I don't like that I left out, where we ask which one has the least increase, and the answer is April to May. And I don't like that because technically, yes, it's the increase that is the lowest, but I would say that the ones where it's dropping are even less of an increase, right, than April to May. So I think that wording is a little confusing. So we try to avoid ambiguous wording when we can. So these are all cases where it's not increasing much. This is increasing a little bit. This is dropping, right? So it's going to be one of these others, and then I can just sort of count. I can go, hey, 40 something to 60, 70 something. That's decent, but the slope kind of gets tighter, and so I can just do very visually. If I just look at slope, the steepest climb is here. I'm going from just basically 100 to over 140. There's my winner. Okay. So I want July to August, D. Okay. The second question is asking about the arithmetic mean for the first half of the year. So just if I look at just the first half, um, a lot of times on DI, it appears that we have to do a lot of calculation. And certainly you could bust out your calculator really quick and you could eyeball these. You have to be fairly precise. So I'd say, hey, this is just under half. So maybe it's like 68 and this is well under. So maybe this is 65. But honestly, what I'd rather do is kind of find the midpoint and say, hey, I've got three that are above 60 and three that are below 60. I don't know that the midpoint's exactly 60, but maybe it's just below. It's something like that. Answer is C. It can't be, if I think multiple choice wise, the answer can't be 70, right? 70 is here. There's only one that's over and it's only a little bit over. That's impossible. So these are outrageous. Um, from a similar perspective, if I look at 50, 50 is here. That doesn't look balanced at all, right? The two below it are just below 50. The ones above it are a lot more, so it can't be 45 or 50. So I've proved 60. And I don't have to calculate. And a lot of times I don't. I have to be precise. I don't want to be really rough, especially if it turned out the answer had to be between 45 and 50. I might need to do a bit of calculation, but I don't want to do more calculation than is necessary. Okay, watching the clock, we'll speed up on a couple of these. Here we're asking, or I'll let you pull this too. In which month was electric cost per Fahrenheit degree of temperature the least? Sometimes the wording can really throw us, cost per Fahrenheit degree. But if I just think about it as I want low cost, high temperature, that would get me there. But specifically, if you think about what that would mean, if I think cost per degree, the lowest, right? I want to minimize this. Notice that in most of them, the cost is greater than the temperature. But in a couple of them, the cost is lower than the temperature. So our only possibilities then will be those, right? If some of them have the numerator bigger than the denominator, those are by definition going to be smaller than the ones where the numerator is less than the denominator. So I want cost over degree to be less than one, since some of them it is. And I'm going to look for one where it's the most like that. If you look at April, they're basically the same. If you look at November, they're very close to the same. But if you look at May, the cost is much less than the degree, right? So if I have if I have lower over higher, then that's less than one. And that gets me May. So again, I don't have to calculate. I don't want to calculate. Okay. Let's pull this one. So this is one where if you're short on time, you might just skip it. But I might say something like this. I might say, okay, they're saying that the ratio of money collected by team A to team B is 5 to 6. But then team A has fewer students. Team A has a ratio of 2 to 3, right? So if I just say, A money to B money is 5 to 6, but A has a lot fewer people, right? 2/3 as many. So I might just ask myself, so which collects more per person? Probably A. And so I want an answer where the first number is greater than the second. A's out, C's out, D's out. It's got to be either E or B. I'm a little nervous about E because E is saying A collected almost twice as much per person. That doesn't seem likely. That would seem like it would only be the case if they had more than half the people, right? Or less than half the people, I should say. Um, one quick way to do this is to make up some numbers. Another way would simply be to say, okay, think about it as like, well, yeah, I'd probably just pick some numbers. So I'd say, okay, let's say A got $500 and B got $600. And let's say A has 2 people. I can just pick the ratio, and B has 3 people. That fits what they told me. Then I could say, all right, so A earned 250 a person. B earned 200 a person. So A to B in this case would be 250 to 200, which is 5 to 4. So that's one way to do it. I personally did it by just multiplying 5/6 by 3/2 by the reciprocal, basically saying, hey, if I have 2/3 as many people, I have 3/2 as much per person. It's not going to make everyone's dreams come true. Oh wait, did I do that? Uh, did I flip that? Oh no, that's right. Yeah. And this turns out to be, oops, 5/4. So if that speaks to you, you can do that. Okay. Number 10, for this one, you'll have to chat in your answer since we can't pull this. Um, again, though, you want an answer bigger than 88 because if the average is 88, the greatest, it's going to be more than that, unless they're all 88. But they've said they're consecutive. So chat in your answer if you have them. One way to do that really quickly would just, well, fairly quickly, honestly, would just be to write them all out. I could just say, hey, if the average is 88 and they're consecutive, that means they're going up by a 1, right? So I'll just, and it doesn't say like consecutive odds or consecutive evens, it just says consecutive. So I'd have 7 in front of it and 7 before it. And they'd have to balance, but I don't actually care about the 7 before it. I just care about the 7 after it. So I could just say, all right, well, that's 89 and 90 and 91 and 92, and I'm writing kind of sloppy. 93. See, I'm not filling in my spaces very well. I might look at that. Okay. And 94, 95. Okay. So I could just count up like that. And if I recognize this, I could even skip writing them out and just say, oh, 7 more after 88. So 88 plus 7. If this had been multiple choice, I could have tried it out. I could have said, okay, what if it were 92 or 93? What would it be? So even without multiple choice, I might say, hey, it's more than 88. How much more? What am I looking for? And use that to guide me. So not, I don't think the hardest problem in the set, but one that I might have trouble with if I'm short on time and I don't have a way to guess. Okay. For this one, we want to know what could be the value of x plus y. Again, lots of ways to answer this, so you can chat in your numbers if you want. But what they're basically saying is x to the power of y is 64. So I have to look at cases. Uh, what are my cases? And here, instead of just testing specific cases to try, I want to know all the cases. So if they're positive integers, I could have a few cases. I could have 64 to the 1. So I say, okay, what other powers will get me to 64? So I could have what's something that I could square to get 64? Oh, let's see, 8, right? 8 squared is 64. Um, what else? Let's see. Is there something to the third power, like 6 times 6 times, that's too big. 4 times 4 times 4, 4 times 4 is 16, times 4 is 64. Oh yeah, look, I can have 4 to the third. Or I could think about it the other way. I could say, hey, 64 is made up of twos. So is there a number smaller than 8 that I can do? Oh, I can do 4. How many 4s make 64? 4 times 4 times 4. Anything else? Sure, I could do 2. How many 2s are there in 64? Powers of 2. 2, 4, 8, 16, 32, 64. 6 powers of 2. So those are all my cases. And then I'm looking for what are x and y in this case. X and y are my base and my exponent. Now the 64 plus 1 is 65. That's not there. They didn't say all the values are there. They just said indicate all such values in the list. They don't have to put all of them. 8 plus 2 is 10. We have to put all that are there, but we don't have to put all the, but they don't have to provide all the possible answers as answer choices. So 10 works. Notice that if at this point I don't have 12, I'm not going to get it. As we go down, we'll notice that the answers get smaller. So I don't have to worry about 12 anymore. 4 plus 3 is 7. But wait, are they going to get smaller? Hold on, 2 plus 6 is going to be 8. Okay, so they don't entirely get smaller, but they're in this range, right? So it happens that I got a range. This didn't have to be a range. Maybe they could have put in a number that we skipped. Like they could have had 9, and then we would have left that out and skipped to 8. But we ended up with 3 in a row. So sometimes when you're testing cases, you have to be exhaustive because they're saying, what are all the things that could happen? So now they're not just saying, hey, find a few things and see what you see. Now they're saying, no, figure it all out, which is can be time consuming, if I'm short on time at the end of a test again. But I might narrow it down and say, hey, I know it's at least this. Speaking of narrowing things down, this is the last one. You can pull this in if you want. But here's one where maybe I don't remember enough geometry to know the curvy part of this circle, right? The arc. But maybe I do know the non-curvy part. And I can use that to my advantage because I can say, wait, if a radius, if I want to know the perimeter of this, I'm wanting the distance around. If a radius is 5, then all the radii are 5. So I know that there's part of this that's going to be 10. And the others all have pi in them. That's probably the circumference part, right? Because circumference is often, if the radius is an integer or it doesn't have pi in the denominator, then we're going to see pi in the circumference because pi is the radius, pi is the ratio of diameter, of circumference to diameter, right? Pi is just take the diameter, multiply it times pi, you get the circumference. And so I can say, hey, the part with pi in it is the green part. The part with just a number is the pink part. And so I can already narrow it down and say, okay, well, clearly I'm going to need to do 10 plus something. And it's not going to work out that I can trade like 5 away for some power of pi because pi is an irrational number. It's not going to trade nicely for something like that. So this is out, that's out. Then I just have to know a rule for this. I could eyeball it. I could say, let's see, the diameter of the whole circle is pi times the diameter. Right? I think of it as d times pi, honestly. Whoever came with 2 pi r, it's like a weird order in which to write things. So d times pi is how I'll often write it. Diameter is 2 radii, so that's 10 pi. So the diameter of the whole circle is 10 pi. And so I could say, but we have less than a quarter. Did I say diameter? Yeah, talk today. I'm mixing up my geometry terminology. Sorry, circumference. The diameter is 10. Circumference is diameter times pi. Say that again. But we have less than a quarter of the circle. So less than 2.5 pi. So I've proven B. I don't need to do all the math. But if I recognize that the idea is 72 out of 360 will tell you what fraction of the circle we have. So 72 over 360 would be equal to our arc that we have over the diameter. Another way to say that is that we have 1/5 of the circle. 72 goes into 360. I didn't say that right. Yeah, goes into it 5 times. And so I gotta have arc over 10 pi like this. So 1/5 of 10 pi would be 2 pi. Have it. Okay. So hopefully this is a useful rundown of just how we're thinking about timing on these sections. Don't take your performance on this particular one too seriously. This wasn't an actual practice test, and maybe this was not quite the level that you'd see exactly, and it might not have the same kind of blend that you'd see on the real thing. Just to get an idea of how we're playing these out, and hopefully a bit of a look of how you review. Although, if we had more time, we'd spend more time reviewing. I usually recommend that you spend several times as long reviewing as you spend doing it. We just don't have time for that in a workshop setting. So stick around if you have questions for me. Otherwise, I want to thank you so much for participating and encourage you to see this on YouTube later and run back through if there's anything that needs more attention. Um, and if you want to check out any of our courses, we'd love to see you. You can always take session 1 for free of any of our in-person or online courses. Thanks, everybody. Have a lovely night. Good luck with your test.